Chapter 7, the last chapter in this course, deals with something called an array. Up to this point, we were able to store data in our program in variable names. Say we wanted to store 3 numbers, we could do something like num1, num2, and num3. But what happens if I want to store 10 numbers? Well, the last thing I want to do is create num1, num2, num3, num4, all the way up to num10. Not a good idea. So if I have a list and the list is homogeneous, meaning they're all the same data type, Java and all programming languages have a way for you to be able to store all of this data with just one name. And as you typed in the code listings, you saw that this new concept, this new idea we're dealing with is something called an array. Okay, so a definition of an array is going to start out with something that looks like int and then empty square brackets, numbers equals new int, and then another set of square brackets. Okay, so I'm declaring a variable name called numbers. It's going to hold the data type int, and when I put these square brackets in, I know I'm going to store more than more than one. I want to store a bunch of numbers side by side in memory that are going to start with this name numbers. So I have int square brackets, numbers equals new int square brackets. In this second set of square brackets, I'm going to put how many items are in my array. For example, 10. And I know it's not easy to see, but you look beside it, I have an array with the number 6, 8, 4, 11, 9, 15, 2, and 1. 2, 4, 6, 8. Actually, I should make that an array of size 8 because I only want to store 8 numbers. Okay, so this is where I declare the size in that second set of square brackets. Now, here's what's happening. This variable name numbers, which I know is an array, basically holds the memory address of where these numbers are in memory that are sitting side by side by side. So when I get ready and say, okay, I want to declare something of type numbers, it gets ready and says, hey, I'm going to create a memory address. And then the second part says how many blocks of memory beside it I'm going to need. So when I say 8, that means I need, well, let's see, an int uses 4 bytes. So 8 times 4 is 32. I'm going to need 32 bytes of free memory. So once I find that location, numbers is going to get that location and be ready to store these values at. Now, we're going to talk about putting the values in and getting the values out and work with them. But right now we're looking at how these numbers are stored. So I go to the memory location of numbers, and the first number I want to put in is 6. And that's going to be stored in a block of memory that is 4 bytes. The next number that I want to put in is 8. So that'll move 4 bytes past where numbers memory location started. And then I would continue to move across and put them in blocks of 4 in consecutive memory locations. Now, how do I get at these guys? What if I want to come in here and say, okay, I'd like to now either store numbers in, change numbers, access numbers? Well, the way we do it and the way you saw in the code listings was I'm going to use subscripts. The very first location in this array is going to be stored in subscript 0. The second one is going to be stored in subscript 1 all the way up to subscript 7. So if I declare an array of size 8, I know I'm going to be using the subscripts 0 to 7. And as you've seen before, a lot of stuff in Java, like strings. My char at, the first character in the string, is char at 0. It goes to location 0. So the way I like to think of this is these subscripts then, like 1, say, okay, so if I want to access numbers sub 1, that means I'm going to go to the numbers location, and then I'm going to take the 1 times 4 bytes so that it moves me over to the spot where 8 begins. First subscript is 0. 0 times 4 bytes would keep me right at that opening location. If I had a subscript 5, I would come to the numbers address. 5 times 4 is 20, and it would know to move across memory 20 bytes. Okay, so this subscript is what I'm going to use to find a location in memory of where I'd like to be in the array. And then when I take that number, I multiply it by 4 bytes. Questions, comments? So far, so good? That is a real quick introduction. Some people teach it. If you go to an apartment may have an address, and then it has little numbers beside it representing the different apartments. Or, so the mailboxes might be laid out. So it's similar to something like mailboxes being laid out. Okay, so the first code listing that you had to type in was code listing 7.2. And inside of 7.2 was a way to fill values. And what's happening is we're going to use an array, because I know, for example, if my array is of size 8, which means I want to store 8 values, I don't want to have 8 individual statements. So what I'm going to do is take a for loop for I equals 0, I is less than 8, I plus plus. So now I is going to be this ever-changing value inside of the loop. And what I can do inside of my loop now, and this is where looping comes into play a lot with arrays, is I'm going to be doing things like numbers sub I, so that I can get number sub 0, number sub 1, number sub 2. So if I wanted to fill it with something, I'd be saying numbers sub I equals, and I might be doing some sort of input. Like in code listing 7.2, you had hours sub index, and again, sub is terminology used to shorten up subscript. So when I say numbers sub I, it's numbers with the subscript I. And then I'm going to use, yeah.
So wait a minute. Isn't the I supposed to like run through this thing, be incremented up to 7? Since if it were to go to 8, it wouldn't work.
Right. And let's on that right now. So my available numbers for an array of size 8 that I declared are 0 through 7. If I tried to do numbers sub 9, I'm going to get an error. The error is going to be called an index. Another name for subscript is index out of bounds. So if you're ever doing something with arrays in Java, and all of a sudden you see this index out of bounds error, that's because you know the subscript is not in the range of what you declared. We declared 0 to 7. So if I try numbers sub 9, I'm going to get this message, index out of bounds. Now, if you take the next course with C++, it's not going to tell you index out of bounds error. It's just going to give you whatever garbage is there. So it'll let you keep putting subscripts in, but it's not necessarily going to stop you. You're just going to get bad data. Okay. So coming back up here, I have this array and this I, which is going to get the values. Again, my for loop is for I equals 0, I is less than 8, I plus plus. That means I is going to get the numbers from 0 to 7. I can use this any way I want then. And like I said, in code listing 7.2, what's happening is we're assigning values. So here you see keyboard.nextInt. So as a number is being typed in from the keyboard, it will store it in numbers sub I. Okay. Next thing I want to take a look at, code listing 7.4. In code listing 7.4, we are taking a look at something called implicit initialization. And you'll hear me use that term occasionally, implicit initialization. So here's an advantage of what we're going to talk about with arrays. If I have 10 numbers, 8 numbers, whatever, I might still be able to read the data in from the keyboard. Especially if I don't know what it is, I'd have to read it in from the keyboard. What if I had 100 numbers or 1,000 numbers? Well, there isn't anybody in their right mind that's going to type in 1,000 numbers. So where do you think these numbers would come from? Good. They come from a data file, a place where a large number of numbers are stored. And what you're going to see for your programs for chapter 7 is I'm giving you a data file. You don't know how many numbers are in that data file. I don't want you to know how many numbers are in that data file, but you're going to read in all of this information from the data file and store it in an array so that you'll be able to work with that data file. So when it comes time to run that program, you're writing what's called a batch program. That means there's no user interaction. It's not an interactive program. It's a batch program. The user hits run and a report will be generated, which is the nice thing about data files. So yes, in chapter 7 with the assignments, we're coming back to a batch program, and we're going to be working with reading big data from a data file. We're going to be reading it in and storing it in an array so that we can have it all saved and work within the program. But what if I know what my data is, and what if I wanted to store it in the array in the program without having to type it in? And in code listing 7.4, it talks about storing in how many days are in each month. Well, that's something that's not going to change. That's not something I want to be typing in. So it's something that I can initialize the array inside the program using this implicit initialization. So in code listing 7.4, you see an array declared called int square brackets because it is an integer array. We give it the name days equals, and now I'm able to fill the data right into my array. You notice I didn't declare size. Well, the right side of it, where it starts with braces, and we all know that January has 31 days, and what's inside of this braces, inside of this set notation, is going to help me with declaring the size of the array and filling it implicitly. So in line 9 of code listing 7.4, you see the set notation, braces 31, and then 28 for February, 31 for March, and so on, so that I can store the number of days in this days array inside my program to get it up and running. Okay? It's called implicit initialization. Questions, comments, complaints? So far, so good?
Yep.
Okay,
Yes.
thank you. All right, so here's what I want you to do now. It's time that we write a code. So I'm going to have you do 2 programs to make sure we're up and running well with the arrays. And the first program, I want you to read 10 numbers from input. So the user is going to input 10 numbers, okay? Once you do that, once you find those 10 numbers, I want you to, well, this has to be a loop, right? I'm going to have a loop to do this. Next thing I want you to do is create a loop that will run through the array and find the largest. We can do this all in one loop. We don't have to have multiple loops. The largest, the smallest, and the total of the 10 numbers, okay? And then I want you to display the numbers, and of course, the largest, the smallest, and the total.
Mr. Farmer, what kind of loop do you want?
4 loops.
Okay.
Now, why a for loop? Remember the definition of a for loop. If we know the exact number of iterations we can just use a for loop because it's going to run that many times. So you're going to have one loop to do the input, to read everything in. You're going to have one loop that's going to do the largest, the smallest, and the total. So you're going to have some work going on in there. So you're going to process through that loop. Then you're going to have a final loop to display all the numbers. What's the largest, what's the smallest, and what's the total. Now, I'm thinking if I need some test data, I might do something like 1, 3, 5, 7, 9, 2, 4, 6, 8, 10. Pretty good test data? Yeah. What's the largest?
10.
10. What's the smallest?
1.
And what's the total? Oh, the total is n times n plus 1 over 2, which is 10 times 11 divided by 2. 10 divided by 2 is 5. 5 times 11 is 55. Any of you ever see that formula before?
I'm literally learning that in calculus like 3 weeks ago.
Is that right? So yeah,
Yeah.
the
I've
sum.
never seen this before. I usually do average.
Okay. Well, I just wanted you to do total, throw something different in. You will be doing average as well. The second program I'd like you to work on is fill an array with 10 names. So now I'm going to have an array of strings, something a little bit different than integers. Okay. Then I want you to ask the user for a name. Once you do that, I want you to search the array to see how many times that name appears. Okay. And here's what I want you to do. I want you to fill this array implicitly. That means I already know the 10 names and I'm going to store them. So start giving me some short names, 3-letter max.
Joe.
Bob, Joe. Remember, these will have to be in double quotes because they're strings. How about Al?
Ed.
Ed. How about Ed again? How about Al again? How about Ed one more time? 1, 2, 3, 4, 5, 6, 7. I need 3 more.
Whatever happened to Eddie?
Tim. I got it. Ed, Ed, and Eddie.
Yes,
Yeah.
yeah, but that's more than 3.
Yeah.
I'm like 3-letter word. We already got Bob.
Tim, Tom, and
May. Really old lady might be named May.
Maeve. All right.
But yeah.
Okay. So there will be your 10 names that you're going to put into this program implicitly. We already know what they are. Okay. So you're going to fill it in. Then you're going to say, hey, user, what name would you like to have? So I'm thinking some test data might be Don because there is no Don. I'm thinking Bob because there's at least one Bob. And I'm thinking your test data, you might want to try Ed because Ed should print out 3 times. Okay.
Yeah.
So 2 programs. First one, read 10 numbers from input using a loop. Second thing, loop to find the largest and smallest and the total. Display the numbers, the largest, the smallest, and the total. And then I want you to also tell me, without using this formula, I just know what the answer is because I used other knowledge. What's the smallest, what's the largest, and what's the total? When you get that one done, the second one is to fill with these names implicitly. Ask the user to see what name they'd like to check in the list and see how many times it appears. Questions?
Do we do this in break rooms or on our own?
I'm going to put you in breakout rooms. Okay.
Okay.
Once I put people in breakout rooms, don't get started just yet. I'm going to see who doesn't want to go in a breakout room, and I may end up rearranging them. So right now we have 10 people. I'm going to create 3 breakout rooms. I'm going to stop the recording here as well.